Hello everyone, welcome to my talk on simplifying multi-cloud observability. In this presentation, we'll talk about multi-cloud observability and why observability needs a different approach in the multi-cloud world. My name is Varma Vegiraju, currently working as a software engineer at Microsoft. I'm a freelance contributor and a book reviewer as well. This is my LinkedIn and email. Please feel free to reach out to me if you have any suggestions or any questions regarding the talk, or if you want to talk about software engineering in general. Let's get started with the agenda. First, we'll talk about what is multi-cloud and why is it gaining a lot of traction. Second, we'll look into what is observability. Third, we'll look at why is observability complex in the multi-cloud architecture. Then we will look at how to simplify it, and then we will conclude the talk. So what is multi-cloud and why is it gaining a lot of traction? Initially, when cloud was just getting started, organizations hosted their services on-prem. Once cloud became mainstream, organizations switched to using both on-prem and cloud. This is what we call as hybrid cloud. Then companies only started using cloud, and if I as an organization use more than one cloud provider to offer my services, that is when I'm on a multi-cloud strategy. As part of a recent survey, 98% of enterprise customers are either switching to or are already on a multi-cloud strategy. And the main motivations, first, data sovereignty. If I have customers worldwide serving in different regions and different countries, I have to abide by the country's data privacy and data protection laws. For example, London has its own GDPR, European Union has its own GDPR. Similarly, United States, India, China, Japan, all of them have their own data privacy and protection laws. It's my responsibility to abide by these laws, and if I find that my cloud provider does not suit my needs, I might choose an additional cloud provider. This is one reason why I would switch to a multi-cloud strategy. Second, cloud vendor login concerns. Imagine I am using a particular service from a cloud provider and somehow the provider decides to either increase the cost of the service or change the service drastically or deprecate the service. I want my business to be resilient to all these factors. This is the second reason why I would choose a multi-cloud strategy. Third, cost optimizations. Every organization or every provider has their own strong offerings. Some offer free egress and ingress. Some offer cheap compute, network, or storage. If I am in a position to utilize all these strategies, I can reduce the cost of running my service on the cloud. So to summarize, data sovereignty, cloud vendor lock-ins, and cost optimizations are the main reasons companies are switching towards multi-cloud strategy. So what is observability? Put it simply, it is the ability to measure the current state of my system. Is my duration high? Is my availability low? Am I matching or am I reaching my SLAs, SLOs, SLIs? Observability helps me answer all these questions. And the three main concepts in observability are metrics, logs, and traces. With metrics, it is a numerical measure of the current state of your system. For example, is my availability 2 nines, 3 nines, or 4 nines? What is the millisecond latency at which I'm serving my requests? And what is the error rate? What is my CPU utilization? All these answers I can get from metrics. Logs are nothing but your diagnostic information. For example, a request failed, then I have to look at stack trace and additional metadata to debug the request. This is what logs will give me. Traces, on the other hand, are becoming popular in the microservices world. Let's say I have this request that has to pass through 10 different microservices and it fails in one of the service. Traces will help me debug these kind of requests. Now, let's look at why observability needs a different approach in the multi-cloud world, and what are the changes that are mandating this. What you see here is a code snippet where I'm just using one cloud provider. What I have is a monitoring SDK that I'm using to emit metrics to a dashboard. Everything is simple because I'm just in the single cloud world. There is nothing complex here, right? Now, in this case here, I am using 2 or 3 different cloud providers. So I have 3 different SDKs, and on the right, I have 2 or 3 different kinds of dashboards. Just looking at this, we can understand the complexity that we are getting into. So let's look at that. Because I'm using multiple clouds, I have multiple SDKs. And because I have multiple SDKs, I end up maintaining all of them. It is either versioning or deprecation or schematics. I'll have to keep tabs of all this information for the SDKs. Second, each cloud provider dashboard is different, and the way they do aggregations is also different. Some sample at 5 minutes, some sample at 1 minute. Now I have to document all this information so that my on-calls understand how to debug a particular dashboard. Now, there's an interesting nuance there. The on-calls, in addition to debugging the service outages, are also debugging the dashboards now. By just hearing that, we know things will get easily out of hand once there's a big fire. Last but not the least, the cost. Now we have to hire more experienced developers who don't come cheap, and also train them, which is also very expensive. So how do we get out of this problem? How do we make things complex for our developers is what we'll take a look at now. If I summarize the problem here, what I want to offer is one single pane of glass experience for my developers. And if I have to offer one single pane of glass experience, I should also be cloud or provider agnostic. And this is where a lot of open source tooling has been helping us, and it is also helping us now. What we are going to take a look at is OpenTelemetry, which is one such open source tool. It is under the Cloud Native Computing Foundation umbrella, and what it simply states is it is a single open source standard to emit your observability data, your metrics, logs, and traces. Second, it is already supported by major cloud providers like AWS, GCP, and Oracle already support this. And the best part, it is vendor agnostic. So let's look at what are the critical components in this cloud native in OpenTelemetry. First, we have the specification. The specification comes into picture when you're implementing OpenTelemetry for a specific language. Because we don't do this daily, we will not get into details here. Next, we have semantics. Remember we discussed about one single pane of glass experience? For that, one important thing you need is a unified schema. With semantics, you can get that. OpenTelemetry SDK is what we will use to emit the metrics, logs, and traces. Before we were using a provider-specific SDK, now we will use OpenTelemetry SDK. By the way, it is available in many different languages: C#, Java, Go, Ruby, and so on. Fourth, what we have is the exporter. Exporter is responsible for translating the metrics translating the observability data from OpenTelemetry SDK into a language that the provider understands. AWS has their own exporter. Microsoft, all of them have their own exporters. And what these exporters do is query SDK to get the observability data and emit to the backend, which is our last piece in the puzzle. The backend is nothing but the cloud provider themselves, AWS, Azure, GCP, or they can be Prometheus, Jaeger also. To summarize, specification required mostly when you're implementing OpenTelemetry in a specific language. Semantics are the way you achieve one single schema. OpenTelemetry SDK is what you use to emit the observability data. Exporter is what you use to translate the OpenTelemetry observability data into vendor specific data. And then you have the backends. Let's look at architecture. So what on the left here is before OpenTelemetry. We have our VM, a service, and the Azure Monitor SDK. Because we are tied to Azure backend, we are using their SDK to emit metrics, which we know is a problem. On the right, what is the OpenTelemetry world? Here, what ends up happening is, instead of the Azure Monitor SDK, use the OpenTelemetry SDK to emit your observability data, and then you use the Azure Telemetry Exporter, which is readily available for us to consume. Just to clarify, the exporter is not a sidecar. It is just another package in C# or a dependency in Maven that you import into your service. And then the exporter does all the heavy lifting of translating the metrics or observability data into a way that the Azure backend can understand, and then send it to Azure. Now what we have done is consolidated our code from using multiple different SDKs to one SDK to send the data. What you see here is a code snippet of how when we are using the OTel SDK. What we have here on the top is the namespace, and then here we have the exporters, and then on the last here is where we are emitting the metrics. Now, if I want to add one more exporter, I just add it to the set of extensions here. And I don't change any of the namespace the way I emit metrics. So the whole process has become simplified. This is an example of how using OpenTelemetry would look when using multiple cloud providers. So here, none of the VM service or the SDK changes. They all remain the same. The only thing that changes is the exporter. Remember, we also discussed single pane of glass experience to see the dashboard. This is where we can use Grafana to export all the metrics data from different providers to Grafana, so that we can offer developers unified experience while debugging through the dashboards. So this is how we can simplify the whole observability stack for our service and make experience seamless for our developers. As multi-cloud architecture keeps growing, it is very important that organizations make vendor agnostic strategy part of their architecture and part of their culture. This is how organizations can keep scaling without any bottlenecks and offer seamless experience to both developers and their clients. Apart from this, there are a ton of other open source tooling also available that have their own exporters and can help query OpenTelemetry SDK. For example, with Prometheus, you are able to export metrics to your own backend. With Loki, it is a log search experience that Grafana offers in addition to metrics. Previously, they only had the metrics. The dashboards only used to show metrics, but now with Loki, you can also see logs. With Zepkin and Jaeger, you can export traces from the SDK to the Jaeger or Zepkin backends. With this, I conclude my talk. Thank you for taking the time to listen to this talk on simplifying multi-cloud observability, and hope you enjoyed it.